This is my demo for Rtos A4 using the Nucleo L476 RG board. In this lab, I'm going to be using ARM's DSP library to compute the FFTs on ADC samples. So in my code, I'm using a timer that externally triggers the ADC at a rate of 2048 Hertz. And then I'm using DMA to basically transfer the samples and then process them via ARM's FFT functions. And then after I do that, on each sample, I'm then calculating and printing both the max magnitude and the max frequency detected for each ADC sample set. So on the left here, I have a wavegen using an 82, where I'm going to be cycling through sine wave, square wave, and triangle wave, or sawtooth, at different frequencies to show that I'm able to detect the max magnitude and frequency. And in the code, basically, once I calculate those, I am printing them via USART to PuTTY. So what I'm going to do first is run my code again and show that it's compiling. Okay, and then that's sending it to the board. So it's flashed, and then you can see it reprinted the max magnitude, max frequency. Everything is 0 right now, and then I'm going to start running it, and then I'll run through them all. So as I hit run, we'll give it a few cycles to get up. Okay, so I'm starting at 1 Hertz. For all of these, I'm running at an amplitude of 1.5 with a 1.5 offset, so the signals will go from 0 to 3 volts. So as you can see, 1 Hertz, that's the max magnitude. I'll then increase it to 523 Hertz. And then as you can see, 523. And then I'll do 1000 Hertz. There we go. So there's 1000. Then I will go to a square wave, go back to 1 Hertz. There's 1 Hertz. Then I'll go to 523 Hertz. Then I'll go back to 1000 Hertz. Perfect. And then the final one, triangle, start at 1 Hertz. Then I'll go to 523 Hertz. And finally, I'll do 1000 Hertz. Perfect. And then on my 82, I was also probing some GPIO pins I'm toggling. The top one is basically how long it takes to go, or basically process all the FFT computations and then also do the USART printing. Here I'm basically toggling a pin high when I start the process, and I toggle a pin low when the process is done. And as you can see, it's taking about 11.1 to 2 milliseconds. And then on the bottom here, I have another pin that's toggling basically when my ADC and my DMA are both sampling and then saving the data. So it takes about a second to basically complete 1 full cycle of a sample time or a sample size and then transfer the data. So my processing time is basically well within the required time to finish the processing before another sample is taken. And that's my demo.